Okay, so the first thing I'm going to do is I've got an L-shaped prism. Now this is called the prism because it's in 3D. It has some kind of depth. Now remember the depth that we add here is that one there. That's your depth, that's your depth, that's your depth, and that's your depth. And this part over here, this is your normal area. You can divide it into two rectangles and add the two areas up to get that area. But once we want to calculate the volume is always given by whatever area you have on top, which is known as your cross-sectional area. It's the area that if you slice this like this all the way through, like this way here, you'll have L's all the way. You'll have L, L's, 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 L's. So that's your cross-sectional area, which is that L shape over there. All right, and then that over there is your L shape. This is let's say this is now 30 centimeters, and let's say this is 10 centimeters, which is your depth. You'll notice that your depth is the same everywhere. This is also 10, and also here at the bottom, because it's the movement that the L shape has moved backwards now or repeated itself 10 centimeters in 3D form.
So we add all the sides?
No. So what we want to do now is we want to calculate the volume. So to calculate the volume, we take the area, the cross-sectional area, this orange part, and we're going to multiply it by the depth. So all we're going to do is take that area that we calculate and multiply it by the 10. Now the depth at the moment we know is 10 centimeters, so I just need to calculate the area, and I will have, but I've got to provide more values. I don't have enough values here, so I'm going to put this as 20 centimeters over here, and I'm going to make this as 20 centimeters over here, and I'm going to make this 50 centimeters over here. So if I want to calculate this, I first need to find, let's say I find the missing side. So I want to find this length over here, and I want to find this length over here. And remember that these two lengths, this length here corresponds to 20 plus 20. So this length is going to be 40. All right, can you see how I did that? So I took the 20 from there and the 20 from there, and I combined it at the end here, and I combined it at the end here to become 40. Okay, 20 and 20. So that's going to be 40 centimeters. So this is 40 centimeters in length, the whole length, as well as the bottom part. Now the bottom one, I do exactly the same thing. If I take this line over here and I move it up there, I got 30 and I got 50. So this is going to become 80. And just to double check that you understand that, so we got 30 here and 50 here. And if I bring that down, because it's perpendicular, it's a block with 90 degrees angles on either side. So that's going to come to a total of 80 centimeters over here. So when I calculate this area, this over here, what's my dimensions going to be for this one? What will this area?
Which one? This one over 30 times 40.
That's it, 30 times 40. And now what's 30 times? Yeah. 3 times 4 is 12. And I put 2 zeros.
And that will be 1,200.
Good. Now I use that same concept and I go to the remaining area over here. And what will that be? What will that be? Do I take 80 times 20 or 50 times 20? 50 times 20, right? Can you see that? Because this one here is going to take that multiplied by that. We don't want to go outside the orange space. That's 1,000, right? That's 1,000 centimeters squared. And now I can add it up. So what's that going to add up to? Add up to 2,000.
So that's 1,000 plus 1,200 equals 2,200.
That's it. So we take 1,000 plus.
So we don't need to do all the depths, right?
Yeah, we only need to use the depth once in our calculation for the volume. And we don't need to use it until we get to this formula. So now that we've got the area done, all we do is we multiply it by the depth now, which is 10. So I'm going to multiply it by that now. We're going to get 2,200 times 10, which is 22,000 centimeters cubed. Make sense?
A little bit, except for the depth part, I understand all the rest.
Yeah, so if I go back to the beginning, let's say I get out of here and let's say I provide new values here. Okay, so I'm going to get new values for this and we're going to calculate the volume. I'll show you quickly. I'll give you a simple example as well. Let's say this is 8. I'll give you all the values as well. This is 4, this is 6, this is 10, and this is, let's say, 4 as well, and this is 4 as well. And the depth, I'm going to choose one of them. Let's make this one 2. If I want to calculate the volume, the first thing I'm going to do is calculate the surface area of the top. So the area of the top will be given by breaking it up into 2 parts. 4 times 8, which will get me 12. Alright, so this is going to be 12 units squared, and that's my area, right? And then the remaining part over here is going to be 6 times 4, which is 24. Only take what you need from there. You don't need a 10, so that's going to be 24.
So for the first pink one, you did 8 times 4?
It's 32. You're right, that's not 12, that's 32. I just added.
What about that other 4?
So this 4 over here is not needed. I mean, if you ignore it, you just need those 2. Can you see that?
You just need 2 of them. Okay.
Yeah, and this one you can also ignore because you just need those 2 as well. Yeah, sorry, that wasn't 12. That was if I added it.
It will just be 32 plus 24
Yeah.
and then 2.
That's it. So 32 plus 24 comes to 56.
And then how do you write the depth?
Now, this is the area. The depth is simply one number, and it's 2. Okay? So volume is going to be equal to 56 times 2.
That is 120.
112.
That's
it. 112, and that's the volume over there. Okay?
Okay.
Alright, so
Should we watch one last video? But
yeah.
Video you're saying?
Yes. Okay.